Chapter 10, page 194. Post-operative care of surgical instrumentation. Within minutes, blood can begin to dry on surgical instruments. Users should take precautions to ensure that blood and soil is not allowed to dry on instruments. To prevent damage associated with dried blood, separate the rings, see figure 10.34, and ratchets for box lock exposure on applicable instruments and cover them with a water-moistened towel. See figure 10.35. Another useful technique is to spray the enzymatic foam or detergent-based solution onto the instruments to prevent blood from drying. With either approach, the instrument should be transported to CS decontamination area as soon as possible. Solutions that damage instruments. Numerous solutions, ranging from those typically used for housekeeping to kitchen-related cleaning purposes, can damage stainless steel instruments. If the solution's container does not specifically note that its intended purpose is for use on surgical instruments, the product should not be used to clean them. See figure 10.36, which identifies common solutions that can damage instruments. The use of saline as a soaking or rinsing agent accelerates the rusting and pitting of surgical instruments. In many cases, the use of saline may void instrument warranties. See figure 10.37. Therefore, controlling instrument exposure to saline is very important. For clinical reasons, operating room personnel cannot eliminate the exposure of stainless steel instruments to saline. However, after the surgical procedures are completed, saline must be removed as an early step in the cleaning process. In figure 10.36, you'll see solutions at the top of page 195 in a chart, solutions that damage surgical instruments. I will read those. Betadine, peroxide, dish soaps, soaking in water, soaking in saline, bleach, iodine, hand soaps, saline, which is the #1 for damage, long-term soaking in rust remover, long-term soaking in stain remover, porcelain cleaners, household lubricants, household powder cleansers, surgeon's hand scrub, and laundry detergent. Highlighted in blue, rusts and stains. Stainless steel is composed of rust-resistant alloys. No steel is truly stainless, although rusting is relatively rare. Proper processing helps control both staining and rusting. Rust that appears on an instrument is often a stain. A pencil eraser can be used for an eraser test to help determine the difference between staining and rusting. After a stain is discovered, use the eraser to remove the discoloration. Then, look at the metal below the discoloration to determine if there are any tiny pit marks. If pit marks are discovered, this is corrosion, the origin of the rusting. If the metal is smooth and clean below the stain, the source of discoloration is a stain. There is no rust. Instrument sharpness testing and identification. Instrument sharpness testing is essential to monitoring the sharpness of surgical instruments. Figures 10.38 through 10.45 illustrate proper sharpness testing procedures for common surgical instruments. Instrument: scissors 4.5 and larger. Test material: red test material latex, orange material latex free. Test: scissors must be able to cut through to the tip 2 or 3 times. The distal tip of the scissors are most crucial portion because this is where they become dull first. They must cut clearly through the tips of the instrument. Figure 10.39. Instrument: scissors 4 inch or smaller. Test material. Yellow test material, latex or latex free. Test. Scissors must be able to cut through the tips 2 or 3 times. The distal tips of the scissors are the most crucial portion. They must cut cleanly through the tips of the instruments. Figure 10.40. Instrument. Bone cutter. Test material. Index card. Test. Cut off a piece of the index card. Figure 10.41. Instrument. Kerosene wronger. Test material. Index card. Test. Punch a clean hole through the card. 10.42. Instrument. Laminectomy wronger. Test material. Index card. Test. The wronger should make a clean bite using half the jaw. Test. Figure 10.43. Instrument. Double action wronger. Test material. Index card. Test. The wronger should make a clean bite through the card. 10.44. Instrument. Bone curette. Test material. Plastic dowel rod. Test. Shave off pieces of the dowel rod. Test figure 10.45. Instrument. Chisels or osteotomes. Test material. Plastic dowel rod. Test. Shave off pieces of the dowel rod. Instrument identification methods. There are thousands of different surgical instruments and many look quite similar. CS technicians must ensure that the correct instruments are placed in the proper trays. Many healthcare facilities use different instruments marking methods to mark instruments for faster and easier identification. Marking surgical instruments for identification can be done in several ways. The use of tape is one popular method for identifying instruments. Although this is seemingly a simple approach, it is important to follow proper application techniques. What follows are some important steps to ensure proper device taping. Clean fingertips with alcohol to remove oils and grease and dirt. Wipe alcohol on the site of the instrument where the tape will be placed to remove any lubricant or moisture that might be on the instrument. Note: tape should always be placed on the shank of the instrument and never the rings. Tape that is applied to a rounded surface, such as instrument rings, will not adhere to the instrument's surface. As shown in figure 10.46, cut the tape on an angle to allow its edge to lay flat. Wrap the tape 1 to 1 1/2 times, 1 to 1 1/2 times around the device. Apply the tape with a firm pulling tension. Be careful not to apply excessive tape. See figure 10.47. After the tape is applied, autoclave the instrument to allow the heat to help bond the tape to the instrument. Figure 10.48 provides an example of properly applied tape. Note: please refer to the tape manufacturer's instructions for use for special instruction. When using tape to identify instruments, inspection of the tape each time the device is processed is very important. Tape that is loose, damaged, or peeling must be removed and replaced, as microorganisms under the loose or damaged tape are very difficult to clean. Peeling and damaged tape can inadvertently fall into the patient, potentially causing an infection. Other methods of marking instruments include acid-based etching. This process can be done by the instrument repair vendor, or a kit may be purchased, so the etching process can be done at the facility. Acid-based etching uses a stencil solutions and electricity to mark stainless steel. This process is semi-permanent, and it can be buffed or off during the instrument repair process. See figure 10.50. Heat-fused nylon. This color coding is often referred to as dipping and is typically done in the repair facility. Heat-fused nylon is a powder-coating process that leaves a thin layer of colored nylon on the instrument. Nylon coating can last years. However, once it begins to chip, all the nylon must be removed from the instrument. See figure 10.51. Laser etching. This durable process is usually done by the manufacturer or an outside vendor. See figure 10.52. Dot matrix. These systems are relatively inexpensive and can be applied by CS technicians. See figure 10.53. The two most popular types of dot systems are the dot marking system, where a small barcode containing the instrument information is applied with pressure-sensitive tape, or the dot peen system is done by using a laser or tungsten stylet to implant the information onto an instrument. Instrument lubrication. Many surgical instruments with moving parts must be lubricated after each use or in accordance with the manufacturer's recommendation. This is also referred to as milking, but is not mentioned in the book. The use of a neutral pH lubricant extends the life of the instrument and makes the device easier for the surgeon to use. While most washer disinfectors will lubricate instruments, some instruments may need to be lubricated again during each assembly. Each CS technician's workstation should have lubrication available for this purpose. Lubricants are available in spray bottle formulas. All lubricants must be approved for use as a surgical instrument lubricant and for the type of sterilization method that will be used on the instrument. The point of application should be the instrument's hinged area or any working component, such as a moving or sliding area. See figure 10.54. Tips to protect instruments from damage. Instruments are an expensive asset for any facility. Protecting the instruments is a part of every CS technician's job. When treated properly, many instruments can remain in active service for many years. The following are some helpful tips. Always follow the manufacturer's instruction for cleaning, lubrication, and sterilization. These instruments were developed by the instrument manufacturer to help ensure the instrument's longevity. Place heavy instruments on the bottom or side of the tray. This will help protect the smaller, more delicate instruments. Select an instrument tray that allows adequate space for weight distribution. Overcrowding instruments can cause damage. All curved instruments should be curved in the same direction to protect the tips from being damaged. Tissue and dressing forceps should be softly nestled together or placed close to each other in the tray or peel pack. Do not push the forceps together. Leave some space between the forceps so the stirlant can reach all surfaces. Delicate instruments should be kept in approved micro cases or small protective cases with the surgical tray. The use of metal instrument holders called stringers can assist in faster sterile field assembly and safer handling of instruments, especially sharps. Stringers also hold instruments in the open position during sterilization. See figure 10.55. Laser finished instruments should never have a metal-to-metal contact that can damage, chip, and scratch the finish during decontamination, tray assembly, and transport. A silicone nipple mat can prevent metal-to-metal contact, as can foam or a lint-free towel. Conclusion. Properly identifying instruments and following the proper inspection protocols help ensure instrument trays are assembled correctly and all the instruments are clean and functional. Carefully following the manufacturer's instruction for use and paying meticulous attention to the detail will help keep the instruments in good repair and extend the life of these expensive items. Central service technicians are the last to touch instruments before they are received in a procedure area. Therefore, their quality of work is critical to successful patient outcomes. Central service terms to remember: stainless steel, scissors, osteotomes, chisel, wrongers, forceps, hemostatic forceps, needle holders, martensitic stainless steel, retractors, cannulas, rib spreaders, suction devices, austenitic stainless steel, serrations, passivation, box lock, jaws, dissection.